All right, ladies and gentlemen, welcome to lesson 91. In lesson 91, what we're looking at is mole ratios. Along with mole ratios, we also are looking at what we call excess and limiting reactants. As the name implies on that, excess, you've got too much. Limiting, you don't have enough. And one of the things that chemists try and do, be it you're working for a big corporation, making lots and lots of chemicals to, you know, make whatever to your, in a trailer making meth. What you want to try and do is maximize your output and minimize your input. If you can maximize your output while minimizing your input, what you can do is make the most money possible, which is kind of the goal of any endeavor in life. So basically, how we do that is we use stoichiometry and this idea that the chemical reaction tells us how much to put together. And if we put it together in the proper amounts, what we get in the end is the max that we can get for the minimum amount that we put into making it. So, anyway, what we want to do is look at something called the mole ratio. And I can do that really quick by looking at the equation that was given to us in the chem catalyst. So let's look at that real quick. We've got two sodium hydroxides coming together with a copper nitrate to make two sodium nitrates and one copper hydroxide. So the idea here is that if we look at the mole ratio, we have a mole ratio of 2 to 1, which makes 2 to 1. And that 2 and 1 just comes from the fact that there's 2 there. There's an unwritten 1 there, just like with math, you don't have to write the 1. There's a 2 there, and there's, again, the unwritten 1 there. And this mole ratio ultimately will tell us, and we'll look at it a little bit more as we work through this problem, what we have too much of, what we have too little of. And in the process, we can think about what we would need to do to maximize getting this copper. I think they're trying to get copper out of solution, if I remember correctly. And so one way we can take chemicals out of a system is through a process of precipitation. And by precipitating it out, it just takes on a different form. It goes to the bottom. Copper can be quite irritating to fish and other wildlife if it becomes too concentrated. So we might want to get it out. And so anyway, this again all leads to the idea, this stoichiometry that's coming in lesson 92. And anyway, let's further delve into this question. It tells me that I've got this reaction that's occurring. The copper nitrate added to the sodium hydroxide tells us the concentrations and the amounts that we have of each. Again, we maybe have 2 beakers, each with 100 milliliters, each with 0.1 molar solutions. Again, we saw from last chapter 14 that if we want to find the number of moles, we take the molarity and multiply by the liters. And so here we would want to take 0.1 molar, which again is a mole per a liter, and multiply it by 100 milliliters divided by 1,000 milliliters per liter is 0.1 of a liter. The liters cancel, and we get 0.1 times 0.1, which is 0.01 mole. And so I think one of the questions was, do we have more moles of one than the other? The answer here is no. The same math would be applied to this one here, and it would say, okay, I've got 0.01 moles of this if I went through the exact same calculation. So I've got 0.01 moles of that as well. So the question then becomes, which one is the one that is in excess? Which one is the one that is the limiter? And so here, what we want to do is inspect our reaction. Our mole ratio tells me that, hey, I need 2 of the sodium hydroxides for every 1 of the copper hydroxide or copper nitrates that I'm using to combine. And so if I've got 0.01 here and I've got 0.01 here, we can see that the excess is definitely here because I only need 1 of those. I would need 0.02 of this if I was going to, because I need double the amount. Now, one thing you have to realize is that you cannot, can I emphasize that enough? Cannot ever do this with grams. It must always be done with moles. If you try and do it with grams, I guarantee you, you're going to crash and burn. Okay, you're gonna miss that problem 150% of the time. Okay, you can't get it right if you go with grams. You've always got to convert into moles somehow. So again, our excess reactant here would be the copper nitrate. I've got too much of it. Okay, comparatively, if I want to look at what I really have, I can divide this by that, and I call that an amount for reaction. And so I would only have 0.005 of this compared to 0.01 of that. If I took 0.01 divided by 1, 0.01, 0.01 divided by 2 gives me 0.005. That's less. And so whichever one ends up with that less reactability, reaction, I don't know what to really call it, but that is how I always try and think of it. And so my limiting reactant then is the sodium hydroxide. All right, so for our check-in, we're going to do something kind of similar to what we did with the chem catalyst. We're going to analyze this chemical reaction of silver nitrate coming together with some sodium phosphate in order to prepare a little bit of sodium nitrate and silver phosphate. Now, you might notice over here that there it is. I put an S on that silver phosphate. How did I know that that would be a solid? Again, if you look at page 459, it says it's a solid. Well, it's also given to you in the equation, but the idea is be checking that 459 table and you'll see every time that something has a little S on it, it's going to come from that table as having an N where the PO4 and the silver meet. So first thing we're asked to do is balance this. You got to make sure anytime you're doing stoichiometry problems that your equation is balanced. So AgNO3, I've got 1 Ag. Over here, I've got 3. So what I better do is put 3 AgNO3s there. Now I have 3 NO3s. I only have 1 NO3 here. So I better put a 3 there. Now I check my sodiums. I've got 3 NAs there. I've got 3 NAs there. I've got 1 PO4 there. I've got 1 PO4 there. And that is now balanced. So my mole ratio you guys should be able to tell me is, dramatic pause for you to yell out the answer at the video. It's 3-1 makes 3-1. Okay. You can always write this as 3:1:3:1. It really doesn't matter. What you have to realize though is that this is not like real math. What you might see at some point is, you might always think, well, 3 and 1 is 4, 3 and 1 is 4. It always has to be that way. You might see some equation where you get 2-3 makes 5-2. And that's a little bit weird in math terms, but the idea is it always comes off of these numbers that are right here in the front. Again, no number just tells me that there's one. Now, the next question is on the check-in is, which combination of reactants results in the maximum amount of product? Can I take A, 1 gram of silver nitrate and 1 gram of sodium phosphate and make that work? The answer there is no way. A, it's in grams. B, it's a 1-to-1 ratio. And it's in grams. No, that one's not going to work. Now, B says I've got 3 grams of AgNO3 and 1 gram of the sodium phosphate. Is that going to work? The answer you should be screaming at the video as I'm talking right now is no, Eirik, no, we can't use grams. No, no grams. All right, so you're right. B is out. Okay, how about C? 1 mole AgNO3, silver nitrate, and 1 mole Na3PO4. Okay, we're at least in moles. We're at least in moles. I like that. But again, I'm looking for a ratio of 3-to-1. This is 1-to-1. So C, not going to work. How about finally D, 3 moles AgNO3, 1 mole Na3PO4. 3-to-1. Boom. That's the one that's going to maximize your output. You're going to use up all of the silver nitrate. You're going to use up all of the sodium phosphate, and you're going to make the maximum amount of silver phosphate that you possibly can. Again, it would precipitate out. You could collect it. Silver's worth money. You could process that. Again, here, it's in solution. It's hard to get silver out of solution without paying a lot of money for electricity. So if you got this guy in solid form, at that point you'd be able to get that silver out of that metal a little bit easier, that compound a little bit easier. So anyway, I hope that helps with lesson 91. If you have any questions, let me know. I think lessons 92 and 93 come Monday or Tuesday, the week of May 4th. Have a great day. Have a great weekend. Take care.